This week we're going to work on the ratio of similar polygons. This started off, we're going to talk about what does it mean for it to be similar. Similar means in simple terms we can just say it's the same shape but has a different size. Same shape but different size, because they wouldn't be similar if they were the same size, because that would make them congruent. Because congruent is same size, same shape, and we all know that wouldn't be similar. It would be similar as well, but we want to make sure it fits that definition. Let's talk about what is a ratio. We've talked about ratios before. So with the ratio, we're comparing the relative value between two like units. And with the ratio, it's usually simplified. So the numbers are simplified out of the way. So instead of using 2/10, you would have 1/5. So usually they're simplified. And they're comparing the same units. What that means is that we're doing like inches to inches. Because if we were comparing unlike units, like miles per hour, that would be a rate. How can we rate a ratio? There's three main ways: A colon B, which also means A to B, and or A over B. So these are different ways we could write it. The nice way to put it is, there's a few other ways you could do it, I believe, but this is how we're going to see in this course. Alright, let's talk about similar polygons. Let's do a simple shape, a triangle. So with this triangle, let's say we have it, this is triangle 1, then we have a bigger one. Triangle 2, we'll call the length A, call this length B. And what this would say, triangle 1 is similar to triangle 2. So that means they're the same shape but different size. And we can kind of see that. So that means all the angles are the same and they're proportional, can create a ratio. So what can we do? Well, we can write it as A to B, or A over B. So there's two different ways we're going to be doing it in this section. So what we first have is side length. We're comparing the side lengths between them. Since they are similar polygons, similar triangles, we can compare it like this. The similar length would be like this. The side length would be A over B. What does that mean? Well, A over B. What does that mean? We're going to write it out what that means again, because I believe that there's a big a lot of people just mess up with these simple terms. So every time figure A, or figure 1, figure 1 has A length, figure 2 has B length. So every time figure 1 has A length, figure 2 has a B length. One thing I do know that a lot of people struggle with is variables, so let's try to use numbers for it. Let's say A is 1. And figure 2b is 5. So this is 1 unit, that's 5 units. So if we write that, it would be 1 over 5. So the side length would be 1 to 5. Well, let's just say we have these two figures, but now A is, let's say that one is 5. Well, that means the 1 went to 5. So it's 5 times bigger. Well, if this is 5, that means figure B has to be 5 times 5, which would be 25. So this is just a quick introduction of this. Let's finish this up so we can get to the examples on what's expected for it. Let's do the similar area. Area figures. So the area of the figures, what would that look like? Well, for this, when we're comparing similar figures, it would just be as the following. We would have a squared over b squared. So a squared, b squared. Oh, that's a little ugly. I'll try to write over it. That's an A. Alright. So if we were to use the numbers, that would be 1 squared over 5 squared. So the area of the ratio between the area of these two figures would look like this. 1 over 25. Alright. That's just an introduction to the ratio of similar polygons.